Welcome back to Innovating with Capella. It's been a while since I've posted, and this presentation that I'm going to be going through today, which is actually going to be delivered in multiple parts of videos, will kind of explain some of the things that's been going on in the past time that has happened since I recorded a video on this channel. What I'm going to do in this presentation is actually go over a presentation that I recently delivered at an INCOSE chapter meeting. This presentation is going to be around delivering the left side of the V with AI enhanced requirement, architecture, analysis, and verification. This is a Capella YouTube channel, so I will feature that as part of the presentation and explain kind of how I got there and why I used it. But it also is going to explain some of the work that I've been doing in parallel around this problem. This presentation is, as you can notice here, I work with Siemens, and I've mentioned that before. But this presentation is my own personal views. Those are expressed in this presentation. They do not reflect the official policy of Siemens. While Siemens has supported my efforts in this area, the content presented does not imply any commitment to deliver any particular products or future capabilities. However, the presentation is for informational purposes. And everything that you are going to see, especially in the next video, that's going to kind of introduce this topic, is actually something that is real. And we will, in this forum, work on seeing all of how it works, and then eventually turn into, with enough interest, if people are interested, I will share how this can be built and how you can do this right now with Capella. So anyway, I'm going to turn it over, run the video. The video, I probably will be cutting it in, but I'm going to start the video. I'll probably cut the actual video content in instead of trying to go through a presentation format. So I'm going to let the video run, and then we'll introduce the other segments of the presentations, which will follow in other videos.
Hey, Tony, thanks for hopping on. We're making real progress on the Rider Diagnostics app here, but still a little bit stuck on how to structure some content for break-related issues here. Needs some solid data to actually drive this.
Oh, that sounds great. I saw your email, and it looks like I can definitely help you out with the system model that I have. I've even spent a little time thinking about putting it all together and how I could do that. So I have here the information that you were looking for. I want to make sure we verify that before I jump in to try to see if we can do something with it. So can you see my screen okay?
Yep, and that looks exactly like what I sent you.
Okay, great. So so you basically, can you explain just a little bit? I want to make sure I got it right.
Yeah, so just kind of like you see there, really need the app to help the rider when anything sort of feels off. So for instance, we're looking at potentially spongy or delayed response in the braking here. We want to just exactly be able to identify what those possible causes are, what related functions may be degraded because of this issue, and try and source some potential resolutions to this issue, some immediate actions, and then maybe some long-term maintenance and follow-up actions as well.
Okay, that sounds, that's kind of what I was gathering from it too. So let me show you what I'm going to use to start with this. So I'm going to basically use a model that I have here, and let me pop that up real quick. This is kind of the model that I'm going to use to kind of do this analysis. It's basically a left brake lever and a right brake lever all the way through to the calipers and then down to the rotors on it. And it's basically our new hydraulic system that we're going to be putting on the bike. So that's what I'm going to use as the basis for this analysis. And then if you have time, we can do this right now. Do you have time right now?
Right now? Yeah, sure.
Yeah, we can do it. We'll do it right now. We'll just do the analysis and put it through. So now what I'm going to do is I'm going to take this model, and this model's already been saved out to Git, so we've got it already up there. So I'm going to jump over to doing the analysis. So this is basically the code that we have here that I'm going to be using. I'm going to modify. I already had code that basically does some reports on what the components are in the braking system. So I'm going to just use that code and we'll tweak it. So that makes it easy. So basically the code just kind of loads up the model. Then it kind of goes through all the elements of the physical architecture. So it actually goes through it. You can see the little for loop here for it. And currently this is basically the analysis that it does. It basically does an analysis of the of a YAML file that I export. And that's kind of what this code is doing here. Exports out this YAML file, and it does the YAML representation and does the analysis on that. And so we can get the information right out of the model. And so right now I'm just going to swap out this code here that we have in here. You can see it's just between these. It's actually a prompt that's going right to AI. It talks about analyzing a component. I'm just going to take this out and we're going to put yours in, and then we can tweak the prompt to your needs with this. And then just do that. Here we go. I worked on the prompt. Okay, so here's the prompt that I have. And I tweaked it just a little bit because you need to make it kind of understand the domain that we're working in. The large language model has to understand it. So I tweaked a couple of things by using terms like a functional chain. A functional chain is a thread of functionality through that system that we're going to be talking about. And that's going to help me get that system effect that you were talking about of what happens from the system perspective. Basically I have here the typical symptoms of the component fails or degrades, likely component causes, how the local component functions related to the system function, recommend writer action occurs for the write, and then any post-write maintenance or an inspection. And so that's pretty much it. This is going to be the prompt, and the prompt is going to get fed down into OpenAI ChatGPT 4.0. That's how it's going to work. Okay, so let me go ahead here, and we'll just hit run, and we'll start seeing it run through it. Okay, you can see there, it's actually generating a graphic to make sure that I got an element of the system. So there's the left hydraulic brake assembly. And then it goes into basically, here's the prompt. And it does take a little bit of time for the prompt to come back with a response. So here we go. This is the information on the left hydraulic brake assembly. It shows the reduced braking efficiency, strange noise when applying the brake, and the brake lever becomes spongy. And then here's the stuff on the likely components. So it actually is referring to the components in the model. So you can see here's left reservoir, left piston, because this is all the left hydraulic system. It talks about the functional chain. So it says that it's going to degrade front braking stopping because the left goes to the front brake, and the local components that are related to it talks about the component, and then recommended writer action if this occurs during the ride and the post-rider checkup. Now it's going on and doing that all for the other components. So you can see it's running through and doing the same thing for the rest of it. So does this look like what you need?
Yeah, no, that's very impressive. That's exactly what I need. But I mean, so it just happens to know all of this. Like we don't have to, generate all these reports manually anymore.
Nope, don't have to do it manually. And one thing it's doing is it's doing a little bit of, it starts with the reference information that's in the model, but then it actually uses its knowledge to add more content to it. And that's kind of what's happening then about recommended writer action. It's basically adding that because of the general knowledge that ChatGPT has. So it's using the model as kind of a reference for it. And yeah, there was no report generated. Now, if you want to change the report, just go and make the report a little different. We can just go in there and you can just change that prompt. That's all you have to do is tweak the prompt. Hey, if you want it in a table format, tell it that you want it in a table format. It'll give you a table format. And what I'm telling you that you can do this. This is just on our SimCenter Studio product. You can I'm going to give you have an access to it. And again, I said that this is up on Git. I can give you the location of where it is up on Git, and you can pull it down, and then you can run the exact same report that I'm running here. So I hope that helps. Is that good? Any other questions?
Exactly what I needed. And honestly, it might just change the way we're building the app, being able to interface with this live prompt access, get all that data in that structured format. Exactly what we need, really bridging that gap there.
Great. Well, I'm glad to help out. So yeah, just let me know if you need anything. I'll send you the link to the Git file and the GitHub location, and you can pull the model down. Okay. Anything else?
Nope, that's about it right now. Thanks.
Okay. Take care, Drew.
Yep, you as well.
So thank you for enjoying. I hope you enjoyed that video. And now and one thing to note is that in the video I did talk about our Siemens product called SimCenter Studio. But this capability could be done also, since this channel is devoted to more open source tools. It could be done on basically Jupyter Lab with some extensions for Git. Which is not a managed application. It's more of you have to install it and run it yourself. But everything you just saw there could be run on that. And so now what I'm going to do is I'm talk about how I got there. How did I get this product, and what was the motivations behind it? And that's what's really going to be the next 3 videos that I'm going to be posting. The first one is going to basically be an introduction and challenges confronting the system engineer. And specifically, I'm going to talk about the promise of SysML V2. The next video after that will be on the current state of general purpose large language models. Of course, this is going to be a moving target, but I can give you the current state as of right now, which is in basically we're in July. Actually, the evaluation I did was about March of this year of 2025. And then the last part is what we can do right now, and that'll be how to leverage a general purpose large language model and MBSE to tackle this left side of the V problem, which is essentially a problem around requirements, analysis and verification, and architecture. And we're going to be using that in the part 3. I'll show how that's all done, and that'll be the last video of this series. And so I hope you'll enjoy the videos. I'm going to go ahead and we'll get ready for the next one, and please subscribe. Thank you very much.